Hi students, this is Ms. Fabrizio coming to you on March 23rd, 2020 for our second online session. I'm just going to share my screen with you so you guys can see my slideshow. Perfect, here we go. Okay, so as always, I'm glad you guys are here. Thank you for showing up. Really appreciate that. And I know that you guys are working hard and you've got a lot on your plates. And again, please do not hesitate to reach out to me through commenting on a video, commenting on Google Classroom, emailing, or texting me. Okay, so our standard for today is a standard HSPS 1-5. And this is talking about the factors that affect reactions. So it's talking about chemical reactions and how we can speed them up, slow them down, etc. So our objective for today, I can explain how gases behave according to kinetic molecular theory, which is something that we touched on before the break. So I'll post those videos for us, or those slides for us on Google Classroom just as a reminder. So there's base assumptions that we have about gases, how gases are measured in terms of temperature and pressure by doing activities. So you guys are going to think about specific activities, about common phenomena that you experience. And then I'm also going to do a little demonstration for us with my makeshift chemistry lab in my house right now. And then also taking notes and performing practice questions. So that's what we're doing today. I'm going to be transparent with you guys, what our objective and what our plan for the day is. Okay, so first, the very top of your packet that you guys have, either physically or online, from the packet that I posted on Google Classroom for this week. So if we cut open a lemon, what happens? So if I cut open a lemon across the room, will I be able to smell it if I walk 10 feet away? If I walk 5 feet away, if I walk 20 feet away, what's going on? So draw a model to show what's happening as you smell a lemon across the room, or if someone sprays cologne across the room. What is happening that you can smell it from X feet away? So pause the video right now so you guys can get your thoughts down, your initial thoughts, what you're thinking. Okay, welcome back. You should have gotten your initial thoughts about what's going on when you smell a lemon across the room. So what's going on with the particles. Okay, and now we are going to do a little demonstration. So first, so our demonstration is we're going to drop food coloring into 2 separate containers of water. So they're both water, tap water just that I got out of my sink. One is cold and one is hot. So the one in my right hand might look like my left hand to you guys. This one is hot, and then this other one is cold. I know they're not the same glass. Hopefully that doesn't affect us. I could not find 2 clear glasses that were approximately the same, like the exact same size. So we're gonna work with what we got. So predict first. So take a minute, pause the video here for number 1 on your packet on page 1. So I can show you guys where you need to be. So we already did our lemon model. So we have 1, 2, 3 questions over here. You can see where my mouse is pointing. So answer question 1. So what do you predict? Pause the video right now so you guys can do that. Okay, welcome back. You should have completed question 1 on your handout. So you should have answered what you think is going to happen when we place the same amount of food coloring into 2 different temperatured waters. Okay, so I'm going to add the same color just in case the different colorings of the dye are what is affecting us. And since it was recently St. Patrick's Day, I'm going to add green. Nope. Okay, so this one is the hot one and this one is the cold one. So what do we see happening with these two? So what's going on with our hot one right here? What's going on with our cold one? So pause the video now so you guys can get your thoughts down for questions 2 and 3. So draw or write down what's going on at the macroscopic. So what's the visual level? What are you seeing? And then the microscopic level. So what's going on with these water particles and the food dye particles? We know that they're both polar. That's why they're mixing together, right? So that's a little review of what we did a couple units ago. So what's going on here though? Okay, pause the video now so you can do that. Okay, welcome back. You guys should have completed question 2 and 3 on your packets. So you should have answered what is going on at the macroscopic level. So what are we seeing? Just literally what's going on here. And then what is happening at the particle level. So here I can show us. So I'm just going to talk us through this and you guys can add or write more as you needed. If you got a perfect answer that you think it's exactly pretty much what I'm saying, then just listen and pat yourself on the back, give yourself a high five because you're rocking it. And if you didn't come up with anything, that's also fine. We're going to talk about it. So what's happening at the macroscopic level, so the visual level? So I would just say at the visual level, the hot water mixed more quickly with the food coloring than the cold water. Like even now you can see it's more thoroughly mixed in the hot water versus our cold water. Now it's becoming more mixed for both of them. Just over time, that's what's going to happen. They're both going to mix because over time, eventually they're going to become like uniform concentration across both. And that's something that we'll talk about in a minute. But I would just say that they're both, yeah, they're both mixing, but the one with the hotter water is mixing quicker at a faster rate. So at the molecular level, I would say that the particles in the hot water, because it's warmer, they're moving faster, right? So hotter particles are moving faster. We know that because when we go from solid to liquid to gas phases, we know that the particles are becoming more farther apart from each other and they're moving quicker. In a solid, in a table, in this glass, the molecules are relatively set where they're going to be because they're not moving, they're keeping its shape, right? Whereas in the water, in this glass, is less set where it needs to be because you can move it around. It fills that volume of whatever you put into it. So if I were to spill it on the table, it would spread out as much as it were able to. Whereas gas is even less in a set state because a gas will not only will it fill any volume you have, but it's going to expand out as much as you let it. So unlike the water that just settles at the bottom, a gas would move out as much as you let it. Okay, so I would talk about or model this with little particles, with little drawings of in the hot water, the particles are moving faster, so that's why it's able to disperse, and the food dye is able to go throughout the water quicker than in the cold water. And right now, again, they're both over time, they're just going to spread out no matter what the temperature of the water, but the hot water is going to get there, get more uniform spread of color faster. Okay, so now it's your turn to think about it. So by the end of class, what do you think these two glasses are going to look like? I know I put a lot of food dye in, so they're kind of already on their way there, and I just kind of gave away the answer. But pause the video now and tell me what, by the end of this video, what we're going to take a look back at that. So number 4, you're answering on your packet. So what are they going to look like? What are these two glasses going to look like? Draw it if you want, but you need to explain why this is happening. So what's going on? What's the difference between these two glasses of green water? Why did one disperse the food coloring more quickly? So pause the video now to do that. Okay, welcome back. By now, you should have completed question 4 on your packet of the mini lesson. So you should have explained why the one water glass is filled or was able to disperse the food coloring more quickly, and what you think they're going to look like at the end of class and why that's happening. Okay, so now that we've done our little experiment with the 2 different colored or the 2 different temperatured waters, same color food dye, let's go back to our lemon model. So draw a model to show what happens again. So if you, in light of what we just learned about temperature and how stuff is carried, so draw another model about how you think that lemon that's opened across the room, that's cut across the room, would get to you. So does temperature, like in these 2 glasses, does that play a role? So on a hotter day, is it gonna get to you faster or slower than a cooler day? So write about that. So think about really if your model has changed at all, and if so, what does that mean? And you are at the bottom of page 2 at this point. So you should be filling that out. So draw your model. If nothing's changed, that's great. Draw it again. I want to make sure you guys got this down. And if something has changed, what does your model have now that your previous model did not? So what are you taking into account at this point? So pause the video, finish that. So answer those 2 questions. Okay, welcome back. So by now you should have by the bottom of page 2 completed in your packet. So now we're going to move on to page 3. So you're going to have some practice problems. And some of the stuff is going to be review of what we talked about before this lesson. And then some of it is going to be kind of exploring more what our temperature is. And I want to just note the temperature is a measure of the kinetic energy of something, right? So it's the measure of something's kinetic potential. And kinetic meaning like movement. And that should make sense because in light of our different temperature waters, the one that had the higher temperature had more movement going on quicker. Okay, so pause the video now to complete the questions on page 3 and 4. So you're gonna finish your packet up. So on page 3 and 4 for Monday, March 23rd, you are finishing your packet. So pause the video to do that. Okay, welcome back. By now you should have completed your entire packet. And that's awesome. So we're going to take a look ahead in just a second. And then I also want us to look at our 2 water glasses. So what do you see going on here? So what you should be observing, hopefully, is that they both have spread the dye throughout the entire water glass, right? So they both are pretty much uniformly green, maybe with a little bit of the dye resting on the bottom. And take a minute now to kind of reflect. So is this something that surprised you? I just realized that I did not have the video full for you guys. So I apologize. Let me look back at that. I just had to sit in the corner. I had myself up in the corner. So take a look. They both are pretty uniformly spread with the green dye. Like I said, with a little bit maybe resting at the bottom. So think about if that's something, is that what you predicted? So go back to what your prediction was on page 2, I believe. So is it something that should surprise you? Did it not? What are we thinking? So take a second to reflect right now. So this shouldn't surprise us. So the only thing that temperature is going to affect is the rate of the reaction. Even though this glass is our cold glass, it's still going to eventually get to the saturation level that our hot glass did. This one just gets to it at a faster rate because the warmer particles are able to move faster and get the dye in quicker. So get it mixed in quicker. So if you guys have any questions about that, please email me or comment on this video or text me so that I know that there's something that we're confused about. So let me know about that, and let me just tell you what is going on, what you should be expecting for the rest of the week. And then this will be the end of the video. Okay, so first I want you guys to let me know how many QPA 1 went, i.e. turn it into me, please. I can't grade anything that you guys don't turn into me. Like, it's kind of, I need you guys to be communicating with me. So I need to know if we still need help with certain parts of it so that I know what we need to go over. So if we're still, some stuff is confusing, because I remember over the break that some stuff was still confusing, the math problems in particular. If that's something that we need to go over, I need to know that, because I will happily go over that with you guys. I just need to know. If you guys are giving me silence and nothing, then I don't know if we need to go over that. And I don't want to waste my time and your guys' time in a video if that's not something that we need to go over. And if it is, that's fine. Like I said, I just need to know. So we're going to have a live session tomorrow on March 24th at 10:30 in the morning. Hope to see you all there. Please come ask me questions. It's a good time to ask me questions if anything is confusing about this video, if you want to talk about the mini QPA, that's the time to do it. And then we have another online video that I'll be posting on Wednesday, March 25th at 10 a.m. So this should be a routine that we're getting in. Every Monday, Wednesday, Friday at 10 a.m. I'm going to post a video for you guys like this, going over a lesson. And then Tuesday, Thursday at 10:30 a.m. we're going to have our live sessions. So again, if you guys have any comments or emails that you need to send me, please do so. You don't have to wait till the live session to do that. Reach out to me whenever, and I'll get back to you in a timely manner. Okay, you guys, you made it to the end of the video. Good job. Real proud of you. Hope to see you at our live session. Have a good night.